Hello everyone. So in last class we saw the Gauss law and different surface areas in Cartesian coordinate system, cylindrical coordinate system and the spherical coordinate system. In this video I am going to explain what are the different application of the Gauss law. We will see one by one. In every video I will explain one by one derivations of how we can apply Gauss law for different systems. So just to recap what we studied in the last class, we studied what is Gauss law. Gauss law says that in a closed surface, the flux lines coming out from that surface is equal to the total charge enclosed from that surface. So we can write psi is equal to d dot ds. Similarly, we know that the relation between B and the E, that is electric flux density and electric field intensity, is equal to D is equal to epsilon naught into E, right? So similarly, we saw what are the different surface areas in different coordinate systems with respect to particular normal vectors. So if you consider the Cartesian coordinate system, we have three surface areas with respect to x, y and z. So one is the with respect to x, when the surface area is normal to x axis, then the surface area is taken as dy dz into ax cap. Similarly, when the surface area is normal to the y axis, we can take dx dz into ay cap, that is a unit vector along with the direction of y axis. Similarly, z axis. So in cylindrical coordinate system, we have three surface areas with respect to rho phi z. Here I taken as r phi z, same as rho phi z. So differential vector with respect to surface area which is normal to r direction is r d phi dz into ar cap. Similarly, with respect to phi, it is dr dz a phi cap. Similarly, z axis it is r dr d phi into az cap. With respect to spherical coordinate system, we know there are three axes, that is r, theta and phi. So with respect to r axis is r square sine theta d phi, and with respect to theta axis it is r sine theta dr d theta, and with respect to phi it is r dr d theta. In this video I am going to explain what is the application of the Gauss law, what is the main use of the Gauss law, where we can apply Gauss law, how we can apply Gauss law. We will see step by steps. Okay? So first, what is the use of Gauss law? Gauss law can be used to find electric field intensity and electric flux density, that is the E and D. So we can, once we get the electric flux density, we can easily obtain electric field intensity. So first application of the Gauss law is we will do the apply Gauss law for point charge. When we consider point charge means very small charge which has very small dimensions. So Gauss law in point charge, first application of the Gauss law is Gauss law in point charge. Also it is called proof for Gauss law. So consider, if you see this diagram, here Q is considered as a point charge which is placed at the origin. So when we place the Q at the origin, whenever charge placed in a particular place, there will be a flux lines produced around that charge. The flux lines will be produced normally in the spherical shape. So I will consider, instead of Cartesian coordinate system, it is in spherical shape. I will consider spherical coordinate system. So in spherical coordinate system, we have three axes, that is r, radius, theta, that is angle made with z axis, and phi, that is angle made with x axis. So we have three components. So now this point charge, I will consider this small area ds, so which is normal to the, which is a part of the sphere and which is normal to the r axis, that is the radius axis. The surface, the normal vector corresponding to this ds area is ar cap. Similarly, I will consider electric flux density produced from this charge is d, which is in the direction of ar cap, or it is in the line along with the line joining between the point charge and ds, point charge and ds. So direction of the d also taken in the direction of ar cap itself. So we can write, when the surface as per in the last class, we saw that the three surface area, one is with respect to normal to the r axis, normal to the theta axis, and normal to the phi axis. But here surface lies normal to the r axis, so we can write the surface area with respect to normal to the r axis is ds is equal to r square sine theta d phi. So if you see the diagram, here the radius is taken as a, so I can write ds is equal to a square sine theta d phi. So unit vector in the direction normal to the surface area is ar cap, so I can write ds vector as a square sine theta d phi into ar cap. I will take that as equation 1. Similarly, we know electric flux density in a point charge is given by equation D is equal to Q divided by 4 pi r square into the direction ar cap. Here r is unit vector, r is a radius, so it is taken as a, so which is equal to q by 4 pi a square into ar cap. Now that is taken as equation 2. Now we know that as per Gauss law, we can write the flux lines produced from that charge is equal to psi is equal to surface integration of d dot ds. So d vector d dot vector ds. So according to from equation 1 and equation 2, if you take dot product of d dot ds, we will get, we know d is equal to 4 pi a q by 4 pi a square into ar cap, and we know ds is a square sine theta d phi ar cap. So if you take dot product of both, you will get this equation. Now d dot ds equal to q by 4 pi sine theta d phi into ar cap dot ar cap, because this q by 4 pi sine theta d phi is a scalar quantity, so we can take outside, so ar dot ar cap we have to take dot product. So we know that the magnitude of ar is 1 because unit vector, this ar also 1, this also unit vector, so the angle between, that is theta, angle between ar and ar is 0, so we know that dot product of any two vector is magnitude of first vector into magnitude of second vector into cos of angle between them. So cos 0 is 1, so 1 into 1 into 1, so it will be equal to 1. So ar cap dot ar cap is equal to 1. Now substituting this, you will get d dot ds is equal to q by 4 pi sine theta d phi. Now substituting equation 4 in equation 3, you will get psi is equal to surface integration of q by 4 pi sine theta d phi. But here limit is taken as phi is varying from 0 to 2 pi and theta is varying from 0 to pi, because in spherical coordinate system these are the limits for r, phi and theta. So r varies from 0 to infinity and phi varies from 0 to 2 pi and theta varies from 0 to pi, because it is a half angle. So integrating and putting limit, we will get this one, and so after simplifying this, you will get the psi is equal to q, that is charge enclosed in the closed surface, which is according to Gauss law. Hence Gauss law is proved. So this derivation is also called proof for Gauss law. Thank you.